Welcome to the Human Factors and Ergonomics Hub, a series of educational podcasts that showcase the connection between human capabilities and good work design, brought to you by the Human Factors and Ergonomics Society of Australia. Hi, I'm Sharon Todd, a certified professional ergonomist and the current president of the Human Factors and Ergonomics Society of Australia. Today, I'm chatting about the Parramatta Light Rail project with Karl Rich. Karl is a certified professional ergonomist with the HFESA and a fellow of the Chartered Institute of Ergonomists and Human Factors in the UK. Karl has over 30 years international experience in the provision of human factors and training in a wide range of safety-critical industries, including rail, oil, gas, marine, process control, medical products, aerospace and defence. Since arriving in Australia in 2017, Karl's projects have included major infrastructure projects such as the Sydney Trains Electrical Isolations Improvement Program, the Parramatta Light Rail and the Melbourne Tunnel Project, to name just a few.
For people that maybe don't live in New South Wales or are not familiar with the project, so the Parramatta Light Rail is a 12-kilometre tramway running down on the old Sydney Trains line, down from Carlingford, all the way down through the city of Parramatta, and then out the other side down to Westmead, and that's known as Stage 1. And Stage 1 has been going on since around 2019, which actually was when I joined the project. And the plan at the moment is that we'll see passenger running in 2024, I think around May 2024. This part of the deal is Stage 1. Okay, so there is another Stage 2, which is going to run a spur off from I think Rydalmere, close to Parramatta, and that's going to run down to the old Sydney Olympic Park. So by the time all that's done, there's going to be a pretty extensive network. In Stage 1, as I said, we've got the run down from Carlingford all the way down through Parramatta down to Westmead. There's a spur off around near Camellia Stop, which is where the depot is, the stabling and maintenance facility. And the stabling and maintenance facility also contains the operational control centre, which is where the trams will be run from, the operational centre through an integrated tram management system. And there'll be 3 operators that sit in the operational control centre, and they will be running the tramways. It's going to be a hop-on, hop-off service, which is fantastic for the people of Parramatta. There are project footfall for the service, but I'm afraid that escapes me today. But it's pretty impressive anyway.
That is really impressive. I didn't realise it was so long, to be honest. So I guess a good question to ask at this point is, what is your role in this project?
Okay, well, I'm a human factors professional. Otherwise, that's why we're here, I guess, for the HFESA. I've been working on major infrastructure projects in various industrial sectors for all of my career as a human factors professional, which goes back quite a number of years now. And back in 2019, the project itself was in a very early stage of the design, preliminary. Well, in fact, earlier than preliminary, actually. So it was just sort of getting out of the concept stage and getting into preliminary design. And there was a human factors integration plan, which is how we manage human factors on these major projects, had previously been written, but there wasn't an HF specialist available to actually execute the plan. Excuse me. So in November 2019, my company was contracted into the project with a view to getting the very early stages of preliminary design underway, updating the integration plan, getting a human factors issues register started, and starting to build a network across the project in order to get all of the necessary human factors activities underway. So during those first 2 or 3 months, I spent that time getting to know everybody, making sure everybody knew what their various roles and responsibilities were with regard to human factors, establishing a human factors working group, starting to get together a specification of human factors requirements, and basically in the 2 or 3 months, just getting things underway. I guess it's a pretty complex contractual arrangement. Okay, so there are lots and lots of different parties, all within this supply, operate, maintain concept, and all of these different partners have all got their role to play with regard to human factors. So I was sitting effectively at the top of the tree, if you will, as the lead HF analyst, to make sure that all the other elements within the contract were actually undertaking their scope of work with regard to human factors. So that was my role, and that took us through the first 2 or 3 months, which got us through preliminary design. So everything the scene was set, if you will, for the work to go on to progress into detailed design. Detailed design is when you get your sleeves rolled up and you start doing all the detail work to make the railway come to life, the tramway come to life, as it were.
You talk about an HF register. I guess this is a nice segue into the next stage, isn't it? So what's on the HF register?
Yeah, okay. So on major projects, the idea is there are two ideas, I guess the two main ideas. The first one is that you ensure that human factors is integrated into the project early. So all of the human factors issues, risks, concerns are all identified. They are risk assessed, so you understand what the implications are for these issues and concerns. And then you either design them out if you can, they're eliminated, the risks are eliminated, or they're reduced to a level which is acceptable to the project so far as is reasonably practicable.
So what are some OSCs that you identified on this project?
Okay, so the risks that you identify, register, and then when you've got them in the register, you then, where you can, associate an action with that issue to close it out. Now, often that action can be a requirement. So these major projects are, they're driven by tens of thousands of requirements, and a big bunch of those would be human factors requirements. So to give you some examples, you might be concerned error in the tram cab. So you want to do everything that you can to ensure that the cab design does not facilitate opportunities for error. It eliminates opportunities for error. So you might have issues on the register associated with the location and grouping of functional controls in the cab, for example, to ensure that the people responsible for the cab design know that they have to meet certain requirements in terms of the functional layout and by priority, by urgency, etc. You may have issues associated with alarm masking. So in the control room, for example, you don't want 2 or 3 alarms going off all at the same time and all with the same tone. So you would have requirements there to ensure that you've got discriminable alarms and only alarms that the operators need to respond to. Okay, so the issues along those sorts of lines. There may be basic ergonomics concerns with regard to the layout of equipment, to ensure that the spatial arrangements for equipment are appropriate for a full range of the likely target audience. In other words, classically in these big projects, it's 5th percentile female to 95th percentile male. That works most of the time, but clearly if you've got a customer-facing environment, then 5th to 95th is not appropriate, because you have to design for the full range, to include people who may have some sort of mobility impairment or a sight impairment, etc. So just saying 5th to 95th is okay, maybe for an operational environment, but not so good for customer facing. So you have to capture those types of issues as well. So a lot of that went on in the early stages of the preliminary design, and then going forward into detailed design when we started to actually do some HF analysis. You may undertake what's called an early human factors analysis. So an early human factors analysis is done at like a workshop forum or document review of concept of operations, for example, and identify what you think the key issues are likely to be. And we've already talked about the issues register, but then those key issues can also be turned into activities. Typically on a project like this one, you may decide that there's not a very clear understanding of what some of the tasks might be. So you'd undertake a task analysis. I've already mentioned opportunities for human error or potential workload issues. So you might do a human error analysis. You might do a workload analysis. You might want to do some usability assessments, for example. So I'm actually talking about a lot of activities that we did actually do. You might want to do some mock-up assessments with physical mock-ups, physical mock-up of the cab or a physical mock-up of the saloons or one of the stops, one of the stations. So there are quite a wide range of activities that you can do, such as those. There are more general ones. So a lot of these projects are very workshop driven. So getting all the right stakeholders in the room and exploring issues or concerns, either in a safety forum or in a human factors forum, and that generates more issues, generates more requirements, or it may generate specific activities. So some activities arise by request. So there might be, someone may have identified a materials handling problem, for example. So you might do a specific materials handling assessment on a particular task, a manual handling task, for example. Although, as you know, Sharon, we do try to eliminate as many manual handling tasks as we possibly can, but sometimes you're left with a residual, and it can't be done in any other way. So you need to make sure that people aren't putting themselves at risk. So there's a bit of a flavour for the types of activities that we undertook during detailed design.
So you talked about assessment. Well, how do you do that? What were some of the things that you did on this project?
Okay, well, we've gone through quite a big usability exercise with some of our partners. Great River City Light Rail, they're going to be the operator. So within our consortium, GRCLR are the operators, and they have helped us and supported us in undertaking usability assessments on the control systems themselves. And the control systems are actually in Florence in Italy. So one of my colleagues, it was really terrible for him. He had to go to Florence with some of the operators and with some of our Italian colleagues, and undertake a series of usability assessments. So the company Thales is building the control systems. So they had the control systems worked up on simulators, and our Great River colleagues and one of my HF colleagues went to Florence, and they undertook scenario-based user testing. So the systems were set up so that various operational scenarios, either business as usual, normal operations, whatever. We had quite a number able to work through. And then it's a combination then of direct observation by the human factors specialist himself or herself, interview, talk through with the operators, getting them to give us observations and feedback, and then finally using more formal usability scales. So, for example, there's the system usability scale, the SUS scale, which is very well calibrated, very widely used around the world, actually. So one of the scales we used was the SUS scale, and the other was a set of questions from Ravden. User metrics in there, usability metrics in there. So we use that too to supplement the information that we had. We then capture all the issues, take them away, write a report, feed them into the issues register. Then they'll go through a couple of loops to get everything agreed. Was this what you said? Yes. Is this accurate? Yes. And then once the consortium has got a configured and agreed set of issues, one of the consortium members then takes those away and implements them to make the necessary changes. It's not always as straightforward as that, because sometimes the operators may request something which actually is outside of the scope of the system, for example. So there are some things that cannot be done, but generally speaking, we do our best to try and close everything out.
You talked about use of simulators. I'm assuming are you using VR in these simulators, or is the simulator mocked up in a physical environment?
Well, that's a really good question. And in fact, there are several parts to this. So the work that was done in Florence was done in their test labs. So there's just a bunch of 24-inch monitors sitting on the desk with a big overview display to replicate what it would sort of look and feel like in the control room. So that's actually using the systems in as a high fidelity environment as is possible. We will repeat those when the control room is built. So there's another round of user testing that's being planned for. But coming back to your point about VR, we did actually use VR for two other studies. So the cab design was done by our colleagues in Spain. And in order to test the cab design with our drivers, our tram operators here in Australia, we built a physical mock-up of the cab dashboard, and it was modelling card and sticky back plastic. We had a proper driver's seat, and we got our drivers. This was during COVID, which was really, really difficult for everybody, but we managed to do it. So the drivers came in, they sat in the driver's seat, and they had this physical sticky back plastic mock-up, but then we put a VR overlay on it. So the drivers put on their VR goggles, and one of the Spanish engineers, one of the CAF engineers, ran the VR simulation. Not interactive. You couldn't reach out and push a button and something would happen, but it was pretty high fidelity and good enough for the physical layouts and for the look and feel. So it gave the drivers, it gave the operators a chance to reach out across the dash. Can they reach everything? Are they happy with the color philosophy? Are they happy with the functional grouping of the controls, etc.? So that was very very successful. We did another a full scale mock-up with the saloon. Okay, so with the passenger saloon, one was built in Spain and it was shipped out to Australia, and we put it in a warehouse in Parramatta. Again, this was at the height of COVID. We planned for 50 people recruited from Parramatta from all the different population segments. So people who they didn't have English as their first language. The anthropometrics, special interest groups, disability groups, etc., sight impaired groups. And then COVID blew it all away. And we ended up with the physical mock-up, and we had to do it online. And how we did it, this is crazy. We had a proxy with a camera who we had all of our subjects online watching, and our proxy walked all around the cab. He went on, he came off, moved around in a wheelchair. We had bikes on board, etc. And it worked, and we got some great results. It was pretty fantastic. I mean, we were so upset that we just couldn't do it. There was no way we were going to get 50 people in a warehouse with COVID, raging everywhere. So despite the limitations, we had this fantastic physical mock-up, and we managed to run people through it. It was really great work by a couple of my colleagues who actually ran it on the day. It was fantastic.
That's a different way of doing things, because it's normally we put people into the space and we observe them and all the rest of it. I wonder whether doing it in this manner prompted them to think about different things that they experience in the space.
That's a good question. Yeah. To be honest, I couldn't give you a specific response to that, but people were very enthusiastic, and we still had rating scales. So people, we designed rating scales, we designed questionnaires, and we still ran that for individuals, and we still ran it as small focus groups. So, aside from we didn't have 50 people in the warehouse, we did manage to get quite a lot of, quantitative, semi-quantitative data. The final piece we did, and this was all VR, we had a digital engineering model of one of the tram stops, Camellia stop, and the digital engineers built a high fidelity VR model of the stop, and we had a room set up in Parramatta, and we got people to come into the room, and they walked around the stop. And, we had trams coming in and out. They couldn't get on the trams, obviously, but we had trams coming in and out. People were able to see all the passenger information displays. They were able to see all of the stop furniture, the seats, et cetera. And we supplemented that with the real thing. So we actually had physical samples of some of the materials that were being used, and benches and and such like, and that was really successful. And I forgot one really important preceding step, actually, because very early on in the design, we built a physical mock-up of the stop, full scale, again in a big warehouse, and there were 40 or 50 odd people that came around the stop and had a look at this big, fairly basic physical mock-up, but it was of a sufficient fidelity to enable people to make comments on things like the benches and stuff like that. So the comments that were made during that earlier physical mock-up were fed through into the digital engineering model, and we were able to demonstrate that we'd closed out previous issues, et cetera. So those mock-ups, VR and physical, they were pretty fantastic, and it was great to work with our colleagues who put so much effort in spite of COVID, which really was a terrible thing in so many ways.
Yes, absolutely. For usability studies, with one person in the room, it's so different, isn't it?
Yeah, absolutely.
Let's sit to the control room then just for a second and talk about the control room. How did you mock up the control room? Was that done with VR? Was that done a real mock-up?
No, we haven't got to that stage yet. And to be honest, it's not a complex control room, but it's pretty simple. We did all the ergonomics calculations from first principles from the drawings. So for sight lines, 5th percentile female sitting at the front, 5th percentile female sitting at the back, etc. The biggest challenge, actually, in a smaller control room, is the sight lines to the video wall. So these overview displays get pretty big, and if you imagine, for a smaller person sitting behind a 24-inch monitor, for example, you've got to get the bottom of the overview display. So trying to avoid people having to move around overly in order to be able to see the display. Of course, people don't sit rigidly in a classic ergonomics posture. People slump and people relax, and we had to take all those calculations into account. So a slumped 5th percentile female sight line to the video wall, for example. All of the furnishings, obviously, they meet Australian standards. So no worries there. The Australian standards are an AS 4442, I think. They all meet good ergonomics requirements, so there's no worry there. Obviously, they're custom built because they have to accommodate a significant number of monitors. But we did all of that and captured all of that through requirements during preliminary and detailed design. So we pretty much specified what the desks would look like, how big they would be, surfaces, surface finishes, etc., etc.
What are they doing in the control room?
Running the trams. So running the timetable, basically. Again, I'm not sure what the headway is going to be, but it's going to be a tram every few minutes. Now, once you set the timetable going, a lot of it is automated, and the drivers drive by line of sight. So it's it's not like a main line, and so they're monitoring the timetable. They are monitoring what's going on at each of the stops. They're monitoring all of the toing and froing into and out of the depot. There's a desk dedicated to customer service. So if someone uses a help point, there's somebody there to respond to that. They manage major events. So if there's a footy game up there, or some other, I don't know, a concert or whatever, and there's additional capacity required at some of the stops, then that's managed too, locally at one of the stops by local staff and via the control centre. So whilst a lot of the systems are automated, they still require quite a lot of intervention and communication between the operators and the drivers, and between the operators themselves.
So you've talked about the drivers driving by sight, and then we've got communication with the control room. So I imagine that some of the human factors work that you've done has looked at driver distraction and things that affect the driver. Can we talk about any of that in this project? I'm not sure where we're at with that.
Well, the line of sight for tram operators. If you've been on the tram in Sydney, and if you've been on the tram going down through Haymarket, for the tram operator, for the driver, it's a complete nightmare down there. There are so many people, so many distractions, so much traffic. You've got low-lying sun, either in your eyes or coming at you from the rear. It's a really, really difficult environment. And there will be places, I guess, in Parramatta where the driver will really require to be very focused indeed. So part of the run down through George Street in Parramatta is going to run through a place called Eat Street, where there's going to be a lot of line side, cafes and restaurants and so on. So the driver does need to be pretty alert. But the design does take account of that in terms of sight lines and visibility. So all of those calculations were done during preliminary design and detailed design to ensure that all the drivers, 5th to 95th range, have extremely good sight lines. There are a couple of other systems on the tram to assist. They're not safety systems, but there's a collision avoidance system on there, for example. So if a vehicle intrudes into the kinetic envelope of the tram, then the tram driver will get a warning. But it's not safety critical because it is line of sight. So there's a lot of dependency on the tram operators, maintaining vigilance and attention. It's a highly interactive job. So it's not I think, underload is, from a workload perspective, is not an issue, I don't think. But I wouldn't say it's not excessive workload either. So I think the balance is probably about right.
Okay, so what have been some of the biggest challenges for you in this project so far? Because it's not finished, which is what you said.
It's a pretty complex consortium of different players. And getting a handle on all of the interfaces between each of these different partners, to make sure that both sides of the interface are under control and being managed. And that's not just a challenge for me as a human factors, that's a challenge for everybody. And we got a dedicated team looking after interface control to make sure that both sides of the interface are managed. I think that's probably one of the biggest ones. Requirements management and closeout. When there are thousands and thousands of requirements and hundreds of human factors requirements, actually getting the evidence together to demonstrate that the requirement has been met, that's a challenge. But again, that's a challenge for everybody, and we're actually in that phase now where we're building this body of evidence to say that all of the requirements are being met, they have been met, they're closed out, and we're getting towards operational readiness and for handover. So when that happens, you've pretty much got to have had it. You've got it done, really, and you've got the evidence for the rail regulator and for the operator to say that we've closed everything. Everything is as it should be. So I guess they're some of the bigger challenges. And then there's the left field stuff that nobody sort of thought about, and it suddenly pops up as a concern or an issue. You think, oh wow, how do we work that one out? And then you end up doing some proper human factors, and come up with an acceptable solution. But it's not usually just me. It's usually it's a collaborative effort. So it'll be me and the safety guys and the signalling guys, or the comms guys, and we'll sit down and work out exactly what is an acceptable solution, because it can't all be about HF. It's about the project as a whole. It's about everybody collaborating and coming up with a solution that's going to work.
So is there anything about this project so far that has changed the way you would integrate human factors in the future?
I think the approach is pretty solid. I think what does change every time is a different set of people, and it's the people thing. And if you go in with a shoehorn every time, this is what we did last time, so this is what we're going to do this time, that's not going to work. You go in there with a basic approach. This is our approach to human factors integration. It pretty well works. If we follow this process, it'll work. But if you put those on tram lines, it won't work. You have to be flexible. Every project is different. Every project team is different. and what worked on one project may not work on another. So a degree of pragmatism is always important, I think. You can't go in there as an evangelist. If you go in there as an evangelist, waving your arms about, saying human factors is wonderful, you might have a bit of a lonely time on the project.
I was going to say that because you talk about the task analysis at the beginning in the hierarchical task analysis about what they do, but every job is ever so slightly different. So I was thinking, how can you can have a basic outline of what the job is based on previous experience. But I was going to ask you how you identify some of those other emergent risks that are there, or needs that you might not have had on other projects.
I think with all task analyses, number one rule is you have a stopping rule. How much is enough? You can't keep analysing. So you only go down to the level where you feel that you've got enough. You've got enough to move forward with the problem. And if you don't have to go all the way down to push button B or push button A, then you don't. At the top sort of level 1, level 2, level 3, for a lot of these tasks, they are broadly the same. Where the delta comes is, well, okay, what's the difference with the way that this system functions? So where you see differences in functionality, that's where the detail lies, and they're the bits that you need to concentrate on. I think another useful way of thinking about this is, what's the safety criticality? How important is this task? So the way I like to think about it is there anything that an operator or maintainer could do which would directly lead to a top event, something nasty? Is there anything that an operator or maintainer could do which might influence that outcome? Or if a nasty event occurs, is there anything that an operator or maintainer could do which would slow down or degrade the response to that? So from a safety criticality point of view, there are three pretty good questions to ask, I think. But it's equally important not just to focus on safety. So there are human performance issues that you need to consider. There are efficiency issues or aspects of performance. There's well-being, or there's like this idea of hedonics, the pleasure principle. Thinking about when iPhones first appeared, they felt great. Everybody loved them because they felt nice in their hands. So it was nice to pick it up and use it. And I sometimes think that part of the job maybe gets a little bit forgotten. So you want to make it a nice place to go. People want to go to work. They don't mind. They want to go to the control room. They want to sit in the cab because it's a nice seat. It feels good. They feel comfortable. I like my workplace. So if you just focus on safety, that maybe becomes a little bit utilitarian. Whereas there's this wider piece about trying to enhance performance and trying to come up with a design which people want to interact with. That's often difficult. And I think finally, I would say you have to say so what every now and again, because if you don't say so what, you end up investigating everything, and there's only you. So you've got to be able to decide what are the really important things and what are the things that, yeah, sure, ideally you'd like to solve them, but you can't do everything. So you need to sometimes focus on those. But, I try and take that to all of my projects.
I think that's a really important thing to think about is where you stop, which is what you're talking about. I think we can achieve a lot more, but is it necessary?
From a design perspective, we know we have designed the cab to a standard that will not propagate those types of injuries. So a lot of care and attention has gone into that, and there have been a lot of lessons learned from other projects which get fed into it. So I think as designers, we've done as much as we can in that regard. in the end, it's an operational concern for how driver well-being is managed going forward.
You've mentioned maintainers, but we didn't really talk about what you've done for the maintainers.
Well, we did quite a lot of work on the stabling and maintenance facility early on. So we ran a number of quite big workshops, either safety or HF led, to ensure that all the major equipment items were laid out satisfactorily, all the clearances, spatial arrangements, etc., working from height, so on and so forth. That was quite a big chunk of work that was done fairly early on during preliminary and early stages of detailed design. The other thing latterly is we've talked about usability assessments for the operators during this later phase of testing and commissioning. We will be doing some ride-alongs with the drivers as well for line of sight assessments for the infrastructure. So just making sure that the snagging really, no one's planted a tree in front of a signal or something. So it's nothing too sophisticated or too detailed, but like a final snagging with the drivers, and we'll do a final walkthrough as well, end to end. Again, just to make sure that there are no unintended consequences. Trees in front of mirrors at stops, or stuff like that. So fairly trivial, we hope, but necessary, I think, just to finish things off.
Thanks for joining us at the Human Factors and Ergonomics Hub, brought to you by the Human Factors and Ergonomics Society of Australia, where human-centred design really matters. If you like this podcast, make us your favourite in your podcast app. We look forward to chatting with you next time.